Welcome back, dear students. This is our fourth lesson for circular measures, and in today's lesson we are going to start solving past year topical questions. Let us start today's lesson. Question number 1. In question number 1, we are given a diagram. The diagram shows a circle with the center O and radius 8 centimeter. Point A and B lie on the circle. The tangents at A and B meet at the point T, and AT is equal to BT is equal to 15 centimeter. This AT is 15, this BT is 15, radius is given 8 centimeter. This is basically sector of the circle whose central angle is unknown. First of all, in the first part we have to find that angle AOB, and we have to show that this is equal to 2.16 radian. So look at this diagram. If I join O to T, you can see that this angle, this central angle, is bisected into two equal parts. For angle AOT, I can write tangent of AOT is equal to opposite over adjacent. Tangent of AOT will be equal to 15 over 8. From here I will write AOT angle is equal to tangent inverse 15 over 8, which will in return give us 1.0808 radians. From here you can see that angle AOB is equal to 2 times angle AOT, which is 2 times 1.0808, which will be 2.16 radian. We were required to show that this angle AOB is 2.16 radian. Now we have to find the perimeter of this shaded region, which is basically arc length plus 15 plus 15. Now we know the angle AOB. So arc length, formula for arc length is L is equal to R theta. R is basically the radius, which is 8, and theta is 2.16. So what will be the arc length? This arc length will be 17.3 centimeter. So perimeter of the shaded region will be, perimeter is 15 plus 15 plus 17.3 centimeter, which is 47.3 centimeter. This was part 2 of this question. Now we have to find the area. Area of the shaded region will be area of this quadrilateral minus area of this sector. And area of the quadrilateral is twice the area of this triangle. What is area of this triangle? 15 multiplied by 8 divided by 2, base into height over 2. So area of triangle AOT will be 1 by 2 into base into height, 60 centimeter square, and area of quadrilateral will be its double, 120 centimeter square. Now area of sector will be, we refer to the figure again, 1 by 2 r square theta. Theta is 2.16. So area of sector will be 1 by 2 into 8 square into 2.16, which will be 32 into 2.16. If you will calculate this area will be 69.12 centimeter square approximately. So shaded area will be area of the quadrilateral minus this area, which will be 50.9 approximately, correct to 3 significant figures, centimeter square. So this was question number 1 of today's lesson. Let us move to our second question. In the diagram AOB, the sector of the circle with center O and radius 12 centimeter. This is radius of this circle 12 centimeter. This angle is given 1 by 3 pi, and we have to find the area of shaded region in this form, a square root 3 minus b pi, and we have to find the values of a and b. What will be our line of action? Okay, area, this shaded area will be area of this trapezium minus area of this sector. Now to find the area of this trapezium, this side is 12, opposite parallel side is unknown, we will have to find this side first. And this side also is the height of the trapezium, this will also be calculated by using this information. What is angle COA? Angle COA is equal to pi by 2 minus 1 by 3 pi, which is pi by 6 radian. From the figure, look out over here, what is sine pi by 6? This angle is pi by 6, this angle we just calculated. Sine pi by 6 is equal to opposite AC over hypotenuse 12. From here I will calculate AC is equal to 12 into sine pi by 6. This AC will be 12 into 1 by 2, 6 centimeter. So this AC line length is 6. This AD will also be 6. Similarly, cos pi by 6 is equal to OC divided by 12. From here I will calculate OC is equal to 12 cos pi by 6, which will give me 6 under root 3, 6 square root 3. So this OC and this AD is equal to 6 square root 3. Now I will find the area of this trapezium. What will be that? Area of trapezium which trapezium? OADB will be equal to 1 by 2 into height, which is 6 square root 3, into sum of two parallel sides. This will be 3 square root 3 into 18, 54 square root 3. And what will be area of the sector? Area of sector will be 1 by 2 r square. What is r? R is radius 12, 12 square. 12 square is 144 into angle, central angle, pi by 3. This will be 24 pi, and shaded area will be area of trapezium minus area of sector. And if I compare it with a square root 3 minus b pi, I will get a is equal to 54 and b is equal to 24. I hope this is clear. This was second question. Let us move to our third question for today's lesson. In this diagram AOB angle is 1 by 3 radian. AOB is a sector of a circle whose radius is 12. This is 12. This OA is also 12. AX and BX are tangent to the circle. They meet at X, and angle AOB is equal to 1 by 3 pi. So what I have to find? I have to find the exact length of AX. If I join O to X, this angle will be half of pi by 3, that is pi by 6. This angle will also be pi by 6. With the help of this, I will calculate. Look at this triangle, OAX. What is tangent pi by 6? Tangent pi by 6 is equal to BX over 12. Implies BX is equal to 12 tangent pi by 6. And this will be 12 over square root 3. which will be 4 square root 3. This is also equal to AX. So we have solved the first part. Now we have to find the area of the shaded region. Area of the shaded region will be equal to area of this quadrilateral minus area of this sector. Area of this quadrilateral will be double the area of this triangle, whose base is 12 and height we just calculated 4 under root 3. So area of triangle OAX, OBX or OAX is equal to 12 multiplied by 4 square root 3 over 2, which is 24 square root 3, and area of quadrilateral OBXA will be equal to 48 square root 3. It's double. Now we have to find area of sector. Area of sector is equal to 1 by 2 r square. R is the radius 12 and theta is pi by 3, this whole angle. So this will be 12 square 144 into pi by 3, which will in return give 24 pi. So area of shaded region will be area of quadrilateral 48 square root 3 minus area of triangle 24 pi. This is your answer to part 2. Let us move to our next question, question number 4. In this question, we are given a diagram. AB is arc length of a circle, center O, radius is R, this angle is theta, this angle is 90, AX is perpendicular to OB. It means AXO is a right angle triangle, and angle AOB is theta. Point X lies on OB and AX is perpendicular. We have to show that area of the shaded region is given by this. How we will calculate the area of shaded region? Area of shaded region will be calculated by subtracting the area of this triangle OAX from the area of sector. Area of sector is very simple. Area of sector is equal to 1 by 2 r square theta. To find the area of triangle, we need to know its base and its height. For that, I can see that from the figure, I can see that sine theta is equal to AX over R and cos theta is equal to OX over R. From here, I can say AX is equal to R sine theta and OX is equal to R cos theta. What is AX and OX? OX is basically base of the triangle and AX is its height. So area of triangle AOX is equal to 1 by 2 base into height, which will simplify to r square over 2 sine theta into cos theta. And from here I will calculate area of shaded region is equal to area of sector minus area of triangle. And I can take out r square by 2 common, and hence we will get area of shaded region is equal to theta minus sine theta cos theta as required. This was part 1 of this question. And in the second part, we are given that r is equal to 12 and the theta is pi by 6. We have to find the perimeter of the shaded region AXB. Perimeter of shaded region AXB. R is given 12, theta is given pi by 6. Perimeter of the shaded region is equal to AX plus xb plus arc length. First of all, let us find arc length. Arc length L is equal to r theta, which is basically r is 12 and theta is pi by 6. So this will be 2 pi. And ax is equal to, as we can, r sin theta, and ox is equal to r cos theta. Ax is equal to r sin theta 12 into 1 by 2, which is 6. Ox is equal to r cos theta 6 under root 3. Now, this is 6 under root 3. This is 12. So, xb is 12 minus 6 under root 3. xb is equal to 12 minus 6 under root 3. Ax is 6 and arc length is 2 pi. So, perimeter of the shaded region will be arc length, which is 2 pi, plus Ax plus xb. Ax plus xb plus arc length AB, which will be simplified to 2 pi plus 18 minus 6 square root 3. This is your answer to part 2. Let us move to our next question. Question number 5. In this question, we are given a diagram. Which shows a circle with center O and radius 5. Okay, this is 5. This is also 5. This is 12. This angle will be 90 because point T lies on the circle and PT is tangent to the circle. PT is 12. Line OT cuts the circle at point Q. We have to find the perimeter of the shaded region. This angle is 90 because PT is tangent to the circle. So I can calculate OT is equal to 12 square plus 5 square, implies OT is 13, and OQ is 5, implies QT is equal to 8. So I have calculated this QT, 8, this distance. This is 8, this is 12, 12 plus 8, 20, and perimeter of this shaded region will be this 12 plus this 8 plus this arc length. And for arc length, I need to calculate this angle theta. Look at the figure. What is value of tangent POQ? 12 over 5, which implies POQ angle is equal to tangent inverse 12 over 5. And if you calculate this, it will give you, this angle will be 1.176 radian. POQ angle will be 1.176 radian. And arc length is equal to r theta. R is 5 and theta is 1.176, which will give you the arc length 5.88 centimeter. And perimeter will be, perimeter of the shaded region will be 12 plus 8 plus 5.88, 25.88. Now we calculate area of this shaded region. For that, we will find area of triangle, and area of this sector will be subtracted from this triangle's area to get this shaded area. Now area of triangle is 12 into 5 over 2, which is 30 centimeter square, and area of sector is again 1 by 2 r square into theta, theta is 1.176, and this area of sector will be 14.7 centimeter square approximately, and shaded area will be 30 minus 14.7 centimeter square, which will give 13.3 centimeter square. Sorry, it will be 15.3 centimeter square. I hope this is clear. Question number 6. In this diagram, the circle has center O and radius 5. This is radius 5. This is arc length 9. This is center O. P and T and QT are tangent to the circle, and we have to find angle POQ. Angle POQ. It's very simple. For angle POQ, I can write L is equal to R theta and theta is equal to L over R, with that L is 9, R is 5. So this will be 1.8 radian. This is angle POQ, 1.8 radian. Now we have to find the arc length PT. If I join this O to T, this angle will be bisected and this angle will be 0.9 radian. And this angle will also be 0.9 radian. In this triangle, POT, what is tangent 0.9 radian? This is equal to PT over 5, which implies PT is equal to 5 times tangent 0.9. And tangent 0.9 multiplied by 5 will give us 6.3 radian. 6.3 radian. So, sorry, 6.3 centimeter, which is length of PT. Now we have to find the area of shaded region. Area of shaded region will be area of this quadrilateral minus area of this sector. And area of the quadrilateral will be twice the area of this triangle. We know the triangle's base and height, 5, and this is 6.3. So area of triangle OPT is equal to 5 multiplied by 6.3 over 2. And area of quadrilateral will be 2 times 5 into 6.3, which will be 5 into 6.3, 31.5 centimeter square. And area of sector is equal to 1 by 2 R square. What is R? R is 5, 25 into radian, angle 1.8. And that will be, to be exact, it will be 22.5 centimeter square. So shaded area will be area of quadrilateral 31.5 centimeter square minus area of triangle 22.5 centimeter square. It will be 9 centimeter square. So this was question number 6. 7th question of today's class. We are given a diagram, circle with center O. There are two regions inside the circle, R1 and R2. Radii OA is unknown, but this angle is theta. This angle will be 2 pi minus theta then. The perimeter of region R1 is equal to arc length of major arc AB. We have to show that theta is equal to this. Perimeter of this R1 is equal to arc length of major arc AB. First of all, what is this arc length AB? L is equal to R theta. And what is perimeter of region R1? This is R plus this arc length. R plus R theta, which is 2R plus R theta. And what is arc length AB? This angle will be 2 pi minus theta. So arc length, this arc length AB will be equal to, arc length is equal to r into 2 pi minus theta, which will be 2 pi r minus r theta. I hope this is clear. We are given that this arc length is equal to this perimeter. So I will write 2r plus r theta is equal to 2 pi r minus r theta. What I have to find? I have to find theta. So I can write r theta plus r theta is equal to 2 pi r minus 2r. And I can write 2r theta is equal to 2r into pi minus theta. And from here I will write theta is equal to pi minus 1. Pi minus 1 over 2. Sorry, pi minus 1, not over 2. This is cancelled with this. So theta will be pi minus 1. This was part 1. In part 2, we are given that area of region R1 is 30 centimeter square. We have to find the area of R2. What is area of R1? Area is equal to 1 by 2 R square theta, which is 30 centimeter square. It means theta is equal to 60 centimeter square. R square theta is equal to this. So theta is pi minus 1. So R square will be equal to R square into pi minus 1 is equal to 60 centimeter square. From here I will write R square is equal to 60 over pi minus 1. And area of sector R2, area of region R2 is 1 by 2 R square into theta, and theta is 2 pi minus pi minus 1. This will be 60 over 2 into pi plus 1 over pi minus 1. When we will simplify it with the help of calculator, we will get this is equal to approximately equal to 58 centimeter square. I hope this is clear. Last question of today's class. This is again related to circle, its sectors and its arc length. We are shown 3 points on the circumference of a circle ABC, and P is also a point with center O and radius 3, angle AOC and angle BOC. This angle AOC and this angle BOC both are 2.3 radian. We have to find angle AOB. Angle AOB is very obvious, is 2 pi minus 2.3 minus 2.3, which will be simplified to 1.683 radian. 1.683 radian. Now we have to find the area of shaded region. Area of shaded region is area of this triangle plus area of this triangle plus area of this sector whose angle we just calculated. This angle we just calculated. First of all, let me find area of triangle AOC. One by 2 into 3 into 3 into sine 2.3 radian, which will be simplified to 3.3557. Same will be area of triangle BOC, 3.3557, and area of sector AOB is equal to 1 by 2 R square into theta. Theta we calculated 1.683, which will be approximately 7.757. Now a shaded area is equal to, we will add up these three areas. 3.3557 plus 3.3557 plus 7.57, and this will be total 14.3 centimeters square approximately, rounded off to three significant figures. We added 1, 2, 3, these three areas to find the area of shaded region. Dear student, this is all for today. In next class, we will further solve some past year questions of circular radius topic for A levels. Please do subscribe this channel and also share it with your students. Stay tuned. Allah Hafiz.